So in Module 4, you have a couple of things to go over for the rational functions. Make sure that you understand discontinuities, vertical asymptotes, and horizontal asymptotes. For the first example, we have a rational function of x squared plus 2x plus 1 over x plus 1. And the question is asking you to simplify this rational function. So the easiest way to simplify is to see if anything can be factored, because if something can be factored, it can be divided out. So in this particular question, if I factor the numerator, which is quadratic, I'm multiplying first times last, 1 times 1, which is 1. So I need two numbers that multiply to be 1 and add up to be the middle number, 2. The two numbers that multiply to be 1 and add up to be 2 are 1 and 1. And over each one of these numbers, I'll put the leading coefficient and split up the x squared. And this represents my two parentheses. It will say x plus 1 for the first fraction representing the first parentheses, and then x plus 1, the second fraction, represents the second parentheses. And you can always FOIL or distribute to check if your factoring is done correctly. If it is, it should bring you right back up to the original line. And then I'm going to bring down the denominator, which I haven't used at all. Again, if it can be factored, it can be divided out. So because of that, the x plus 1 and x plus 1 can be divided out, leaving you with just an additional x plus 1. So it's simplified. And for the second rational function, you have 2x plus 5 over 3x minus 1. I'm going to rewrite it so that you can kind of see it a little better in fraction form. Now, a vertical asymptote is what x can never, ever, ever be. They're known as the zeros of the denominator because you can never have a zero in your denominator. So anytime you're looking for a vertical asymptote, you can simply just set your denominator equal to 0 and solve for x. So I would add 1, whatever I do to one side, I do to the other. 3x equals to 1. And then x is being multiplied to 3, divide both sides by 3. And your vertical asymptote is x equals 1/3. If you were to plug that x in, it would give you a denominator of 0, so that's what makes it your vertical asymptote. For your horizontal asymptote, you always want to look at the degrees or the highest exponent for x in the numerator and in the denominator. So if you look for x, the highest power is 1. So the numerator's degree is known as n. And for the denominator, the highest exponent or degree is also 1. When there's not a power there, it's a power of 1. So m also equals to 1. And then you refer back to the table. If n is less than m, then y equals to 0. We don't have that. If n equals to m, which is what we have, then y equals a over b, which is a is the leading coefficient of the numerator, and b is the leading coefficient of the denominator. So y will equal, your horizontal asymptote, y will equal to the two leading coefficients, which is 2 over 3. I hope this helps.